Hello, friends. Today we are going to see another interview problem, which is find the maximum depth or height of a binary tree. So, given a binary tree, you have to find the height of it. So, let's take a look um, at this example. So, let's say this is a binary tree given. So, what is the height? So, height is nothing but the uh, find out the deepest node and find the distance between root node. So this is your root node. This is your deepest node, right? Deep, deepest node. So the distance between the deepest node and the root node, that becomes the height, right? Let's say, for example, if this is not given, this entire thing is not here, then what is the height? So this is in that case, these two are the deepest node. So 1, 2, 3, 4. So height would be 4. And in this example, this is the deepest node. So this is 1, 2, 3, 4, 5, 6, 7. So height is 7. So yeah, so let's say if you have 5 more nodes here or 6 more nodes here, then 6, and then 7 and 8, then height would be 8, right? So now find the deepest node in a given tree and find the distance between root node and the deepest node. That becomes the height of a tree. So let's go to a blackboard and see how we can solve it. So yeah, this is the same tree which we just saw in our example. Um, so first of all, we are going to use recursion, and we'll start from the root, and we will go down to left and the right, and we'll keep going left and right. Once you hit the leaf node, so what is the leaf node? Leaf node is the one which doesn't have any child. So the left is null and the right is null. So this is a leaf node. So once you hit the leaf node, you will backtrack. And once you backtrack, what you will return? The height of left subtree. So the left height and the right height, you take the maximum of that and add 1 to it. So in this case, when the left child and the right child both are null, these will return 0. This will return 0. So in this case, it will return max. So max of 0, comma 0 plus 1. So this node will return 1. Similarly, this is a leaf node. So this will null, null. So this will return 0. This will return 0. So the node 50 will return 1 plus max of 0, comma 0. So that is 1. So this will return 1. Now the node 45, uh, the right child of the 45 node is null. So this will return 0. And from here, we get the 1. So it would be 1 plus max of 1, comma 0. So that is 2. So the 45 will return 2, right? Similarly, here, this is null. So this will return 0. From here, we got 2. So it would be 1 plus max of 0, comma 2. So that would be 3. So 40 will return 3. Similarly, 35 will return 4 and 25 will return 5. Now here, 30 returns 1. Here this is null, so this will 20 will return 2, right? So at the node 10, from the left side we get 2, and from the right side we get 5. So the max of 2 comma 5 plus 1, so that is 6. So 10 will return 6. Now this right child of 5 will return 1. So now at the root, when you backtrack back to the root, you will have 6 coming from the left. Left height is 6, right height is 1. So you will return 1 plus max of 6 comma 1. So that is 7. So this will return 7. So that's the height of a binary tree in this case. So let's go back and to our problem. Yes, so approach is simple. Get the left height of left subtree, say left height. Get the height of right subtree, right height. Take the max of left height and right height, add 1 for the root and return. So when you make a recursive call, initially this will be a root. When you make a recursive call, this will be the root, this will be the root. So you will add 1 plus max of left height and the right height. So let's see the code. Yeah, the code is pretty simple. First, let's see our node. So node is pretty standard. Like it has a left child, right child, data, and this is the same tree which we saw in our example 5, 10, 15, 20 up to 50. So this is just a one line of code. That's the power of recursion. So this is a base case. So when root becomes null, return 0. So that will happen once you reach to a leaf. So this will be null. So you will return 0 from left and right. So if you see, you make a recursive call and get the left height, make a recursive call to the right and get the right height, get the max from left and right, add 1 and then return. Yeah, this is just a one line that will give you the height. And let's run this code. So yeah, this looks good. Now let's run the code, and the height is 7. Okay, so yeah. So um, we can mark this problem as completed. So getting the height of a binary tree can be used uh, solving can be used in different problems. Like this is useful when you find a diameter of a binary tree, or if you have to find if you have given a binary tree and a node and you have to find depth of that node, you can use the same concept. So this is pretty useful concept, finding the height of a binary tree. Um, and yeah, you can visit our website for more interesting problems, tutorialhorizon.com, and we'll see you guys in the next video. Bye bye.